Okay, so let's talk about monopoly versus short-run competitive equilibrium with a single firm. Okay. So monopoly versus short-run competitive equilibrium with a single firm. Okay. Okay. So the biggest difference is a monopolist is not a price taker. Okay, so monopolist is not a price taker. Okay, okay, and of course the competitive firm is a price taker. And because monopolist is not a price taker, monopolist does not have a supply curve. Because the idea behind supply curve is, given this price, what do you want to supply? Given that price, what do you want to supply? Since you are not a price taker, you don't have a supply curve. Okay, fine. Okay, so monopolist, no supply curve. Okay, of course, competitive firm, yes, there is a supply curve. Okay, so how do you find a monopoly equilibrium? Okay, so this is how you find the monopoly equilibrium. Of course, we'll be given some demand function. If we are not given a demand function, we'll be given some utility functions from which you know how to find the demand functions. So whatever is the case, the key thing is, given the demand function, monopolist is just going to choose a point on the demand function that maximizes his profit. Okay, so if you keep this in mind, we can just write the maximization problem keeping this in mind. Okay, fine. So this is what the monopolists do. Okay, so monopolist actually chooses two things. One is the price and the other is the quantity. Okay, okay, let me write PMQM. Okay, in such a way that it solves the following maximization problem. Okay, so monopolist's choice, let me just write PMQM is a solution to the following problem. Okay, so what is the problem? Problem is maximize profit. So so what is profit? Revenue minus cost. Okay, so price times quantity. Okay, minus the cost of producing this quantity. Okay, with respect to P and Q, subject to the constraint. So let us say you are given the inverse demand function PDQ. So subject to the constraint that P must be equal to PDQ. Okay, where this function and this function will be given to you. Okay, you'll be given the cost function and you'll be given the demand function. So if the cost function is not given, then in that case the production function will be given, from which you know how to find the cost function. Okay, and if the demand function is not given, then in that case you'll be given a utility function from which you know how to find the demand function. Is that okay? Fine. Okay, so this is the monopolist profit maximization problem. Choose a point on the inverse demand curve that maximizes your profit. As simple as that. Is that okay? Clear to everyone? Any questions? No? Okay, good. Now let me tell you the comparison between the problem that you solve for short-run competitive equilibrium with a single firm and the monopolist monopoly equilibrium. Okay, so this is a problem that you solve for short-run competitive equilibrium. You first find the supply curve of the competitive firm. Okay, so just pay attention to the problem that the competitive firm will solve. Okay, so step one, find the supply curve of the competitive firm. So how do you do that? Okay, so this is what you need to do. You just need to solve this problem, because it's a competitive firm, it will take price as given, so it will take P as given. Okay, and again it's going to choose Q. Okay, minus CQ. Is that fine? Okay, that's it. You solve this problem. Okay, so when you solve this problem, you get the supply function. Is that clear? You get the supply function. So if you want, you can write the inverse supply curve, or if you want, you can write the supply curve, whichever way you like. Okay, so when you solve this problem, the solution will be the supply curve. Okay, because it will depend on price. You keep changing price, the solution keep on changing. Okay, step two, the competitive equilibrium, okay, or the short-run competitive equilibrium is the price quantity combination. Okay, so it's basically like this, PCQC. Okay, fine. Basically is on the intersection of demand curve and the supply curve. Is that okay? Fine. Okay, so basically if you want, you can write this, that uh, so uh, so so it will be basically in this intersection. Okay, so let me write that intersection. Okay, is okay, so this is let's use this inverse demand function. Do you want me to use inverse supply function or inverse supply, or do you want me to use uh, mm, well, let me use inverse supply. I think that's just the same thing, right? I mean, just you can write it in inverse form. Okay, so PSQ, fine. Okay, so short-run competitive equilibrium is on the intersection of the supply and the demand. Okay, so let me just write that. Okay, so is is basically PCQC belongs to. Okay, PQ such that P is equal to PSQ is equal to PDQ. Is that fine? Basically, it gives you all those price quantity combinations at which demand equals supply. Have you understood this? That's it. Okay, this is what you do in the short-run competitive equilibrium case. This is what you do in the monopoly case. Now we can just do that through picture, just to give you an understanding of what is going on. Okay, so so the monopolist, it's a simple problem. You are given the demand, Let's say this is the demand. Okay. This is quantity. This is price. This is the demand curve. Okay. So the monopolist chooses a point on this demand curve that maximizes profit. Clear? Okay. So monopolist doesn't have any kind of supply curve which intersects with this or something like that. No. Okay. Monopolist will just take a point on this demand curve, figure out which point on the demand curve yields the highest profit. Okay, and that's it. That's what the monopolist will do. Okay, so monopolist picks a point on the demand curve that maximizes the profit. Okay. Now, what about this single firm competitive equilibrium case? Well, in this case, for the single firm competitive situation, you can just completely, because this firm is actually, it doesn't even care about, there is a demand curve. It just it's because when it solves this problem, do you agree we don't even take into account the where is the demand curve, right? I mean, it's just, do you agree? Okay. So basically what the single firm do is this, for every price, okay, for every price it is going to tell, I mean, how much it wants to sell. Okay, so at this price it is going to say that, okay, this is what I want to sell. Okay, at this price it is going to say this is what I want to sell. At this price it is going to say, okay, this is what I want to sell. Okay, at this price it is going to say, okay, this is what I want to sell. Okay, and then you just connect them. Okay, and that gives you the supply curve. Notice that this is the step one of the problem. Okay, now once you have done this step one, step two is, okay, look at where the demand and the supply curve intersect. Okay, now you put the demand curve in the picture. Okay, so this is demand curve. And basically the competitive equilibrium is this, where demand equals supply. Okay, so this is QCPC. Have you understood? Can you see the difference?
Yes, sir.
Okay, so obviously the monopolist has the flexibility to even choose this point, right? Because this is on the demand curve. So monopolist could have actually chosen this point, but it can also choose some other point. Okay, this is not the flexibility that a competitive firm has. Is that fine? Okay, so obviously, because of this flexibility that the monopolist enjoys, monopolist will earn more profit. Yes or no? Have you understood this? Just straightforward, because monopolist could have easily chosen this point. Okay, so the point that is the competitive equilibrium, short-run competitive equilibrium, is one of the point in the choice set of the monopolist. And since monopolist picks the best point from his choice set. So monopolist will make at least as much profit as a single firm, in a competitive environment will make. Is that fine? That's a proof. Have you understood this? Okay. Any questions? You want to do one more problem and just quickly verify this? Okay, let's do one more problem. Okay, so uh, suppose the demand curve is this. Okay, P equals max of 10 minus Q comma 0. Okay, and the cost function is CQ equal to 2Q. Okay, so what you have to do is find the short run competitive equilibrium in this case, and also find the monopoly equilibrium in this case. Compare the profits. Do it. You have 5 minutes.
Sir, in case of the shortened comparative equilibrium, the price will be 2 and the quantity will be 8.
Very good.
And in case of monopoly, the price will be 6 and the quantity will be 4.
Yes, that's right. Okay, very good. Okay, so let's quickly do this. Okay, uh, so I mean, you can just find the supply in the usual way. We have already seen that. Okay, so this is the supply. Okay, of a single firm competitive in the competitive environment. Okay, single firm that is competitive. Okay, so obviously it will be uh, 0 if P is less than 2, right? And if P is equal to 2, then the firm is willing to supply any non-negative quantity. Okay, and if P is greater than 2, then the firm would want to supply infinite amount. Okay, so there is no finite solution to this problem. Okay, so again, we'll to find the competitive equilibrium, we'll just look at the intersection of the demand and supply. So one way is just looking at it. Let me also tell you the other way using the picture. Okay, I mean, we can easily do this just by looking at it, but you should also know how to draw the picture. Okay, so how do you draw this picture? Well, let's first plot the demand curve. Okay, so the demand curve will look like this. It will be a 45-degree line like this. Okay, 10, 10, right? Okay, and what about the supply curve? Well, the supply curve, so for P greater than 2, the supply is 0. Okay. Sorry, for P less than 2. For P less than 2, the supply is 0. Okay, so what that means is, let's say if this is 2, okay, then for P less than 2, the supply is 0. Okay, for P equal to 2, everything is a supply. Okay, so here we have demand equal to supply. Okay, so what is the competitive equilibrium? Competitive equilibrium is this point. Okay, which is PC QC, which is basically, or let me just write it in that order. Okay, QCPC. Okay, QCPC, which is what? So PC is 2. Okay, and QC is basically, just use the demand curve, you'll get 8. Is that fine? Okay, now let's find the single firm in the monopoly environment, you know. Okay. So single firm that is a monopoly will actually solve the following profit maximization problem. We can actually ignore Q greater than 10. Anyways, the monopolist firm will not choose Q greater than 10 because then price will be zero and there'll be some negative, uh, there'll be some loss. Okay. So obviously, and we can ignore Q greater than 10. So we can simply write the profit maximization problem as choosing. So of course, you are actually choosing both price and quantity, but I know the relationship between price and quantity is P is 10 minus Q. So I can convert it into a one variable optimization problem by replacing price by 10 minus Q. Okay, fine. So this is just choosing Q. Okay, and between 0 and 10, of course. I can ignore Q greater than 10 as I've just told you, because beyond Q equal to 10, the price will be zero. So the revenue will be zero, but the cost will be positive. Okay, and that would lead to losses. Okay, you can always ignore losses by choosing a price greater than 10. Then, because in that case you will not sell anything. Is that okay? Basically, you can choose Q equal to zero. That's the point that I'm making. So if you can choose Q equal to zero, then you'll make no profit, no loss, which is better than setting a price, which is better than basically selling Q greater than 10. Yes or no? Okay. So we can ignore Q greater than 10. So if we ignore Q greater than 10, then the profit maximization problem is straightforward, which is Q into 10 minus Q minus 2Q. Okay. Right? That's it. Now this is actually very simple to solve. It's actually a nice concave function. Okay, and you can just take the derivative, set it equal to zero. Okay, and you'll get the solution. Okay. So take the derivative. Okay. Q minus 2Q minus 2. Sorry, 10 minus 2Q minus 2. Is everyone getting this? Okay, and set it equal to 0. Okay, and you can see that this quantity actually lies between 0 and 10, and it's a concave function. So you will get, how do you know it's a concave function? Second derivative is minus 2. Okay, it's negative. So it's a concave function. So the first order condition is both necessary and sufficient. Is that okay? Fine. So just solve it. What are we going to get? QM is 8 by 2, which is 4. Okay, and what is PM? PM is 6. Is that clear? So that's your monopoly equilibrium. And you can see that it's different from the competitive equilibrium. Okay. Both situations have one firm, but because the environment is different. In one situation, firm is a price taker. Another one, it's actually choosing a price. So that's why there is a difference. Is that clear? In this case, you can see the profits are zero. Even though there is just one firm in the industry, still it makes zero profit. Okay, but in this case, you can see that the profits are not zero. Okay, this is just positive. So what is the monopoly profit? By M is 24 minus 4 into 2, which is 16. Okay, and pi C is 0. Is that fine? Have you all understood this?
Sir,
Yes.
when is it possible that the monopolist also chooses the same optimal as the perfectly competitive single firm and does not cause any sort of distortions in the market?
Okay, so it depends on the demand curve. Okay,
I
and it also depends on the cost curve. Okay, so I mean, you can construct situations where this can happen. There can also be, a little bit, if I introduce some kind of discontinuity in the costs, okay, then it's possible to construct examples where monopoly will give you the same, uh, outcome as the single firm competitive equilibrium. Okay, I mean, eventually you're basically, I mean, you can invent functions. I mean, it's something which is possible. Okay, you, you are solving some problem here, some problem here. So you are asking in what situations the solution will be the same. Okay, so it is basically possible to come up with a function like that. I mean, you just have to play with demand function and cost in such a way that the solutions coincide. So maybe you can just take it as an exercise. Think of a function, think of a demand function, think of a cost function, so that the two solutions coincide. Okay, it's a good exercise. Try it. So fine. Okay.